Hello everyone, welcome to the 8085 instruction set series. So in this particular session we'll study about the rotate instructions of 8085. There are 4 rotate instructions, 2 for right and 2 for left. In this session we'll study about the rotate left instruction. So there are 2 rotate left instructions. One is RLC, rotate accumulator left, and the other is RAL, rotate accumulator left through carry. So let us first see the RLC instruction, that is the rotate accumulator left. So this is a 1 byte instruction. It rotates the contents of register A left by 1 bits. So we will take some data in register A that will be in hexadecimal, and we will denote in this binary notation also. So A contains 1 byte data and we will denote in binary in bits in this different columns. You can see this. So we also have the carry flag. Okay, we need the carry flag to understand the operation. So let us assume we have a data 55H in register A. Now 55H in binary is this 01010101. So this 1 number is of 4 bit, the other 5 is also 4 bit. So 50101, other 50101. Now let us assume that carry flag is already set. We assume that carry flag is already set, and we have the bits. We denote the bits. The rightmost is D0, then D1, D2, D3 up to D7. The leftmost bit, the most significant, is D7 bit. Then let us see what happens with RLC instruction. Suppose if we give RLC instruction in this particular state, what will happen is that D0 will shift to D1, D1 will shift to D2, D2 will shift to D3, D3 to D4, D4 to D5, D5 to D6, D6 to D7. Now this we must understand properly. What happens to D7? So D7, it shifts to carry, and D7 also shifts to D0. Okay, so this is one of the basic difference between RLC and RAL that we'll see afterwards. So this is what happens. So in this case, what will happen? Let us see. See, this is how the bits go on shifting. Okay, so they are shifted in this way, and of course the carry which was there in carry flag, it is lost, and we have this data 10101010. Okay, and because now the new data is 1010 and 1010, so this 1010 is A and 1010 is A. So 55 becomes A and carry flag A becomes reset. So this is how RLC works. Now we see the instruction RAL, that is rotate accumulator left through carry. So this is a 1 byte instruction. It rotates the contents of register A, that is the accumulator, left by 1 bit through the carry. So we again do this one with the example, the same example we used in the previous case. So we have register A, it contains the data 55. So we denote 55 in binary 01010101, and assume that the carry flag is already set. So these are the bits. We denote them D0, D1 up to D7. Now if we execute the instruction RAL, what happens is that D0 shifts to D1, D1 shifts to D2, D2 D3, and so on up to D7. Now what happens at D7? So D7 shifts to carry, and carry shifts to D0. So this is the basic difference between the RLC and RAL. In case of RLC, the D7 bit, it shifts to carry as well as to D0, but here D7 shifts to carry and carry shifts to D. Therefore it is called as a through carry. Now what happens in this case? Okay, so this is the shifting. Okay, this shift, every bit shift left, and here we have the final output. So this 55 will change. So this is the data 10101011, and so this what we get is 101 A and 1011 is B. So in this case the output what we get is AB and carry is reset. So this is how the rotate left instructions work. So that's all for this particular session.